Hey guys, Danny here again. Welcome to Information Design, Week 4. So this week we are going to be focusing on the psychology of information design, and we're also going to be doing a little workshop on how to use the charting tool in Illustrator. So far we've gone through the entire data pipeline, and we're at the end. So we've already gone through collecting and sourcing data, scrubbing data, analyzing data, visualizing data for insight, and today we're going to be talking about visualizing for presentation. Before we could put pen to paper or open up Illustrator and start designing, we first have to understand why we need to visualize data at all and the best way to visualize these data sets. From birth, we are all very visual creatures. It's just part of who we are as humans. When it comes to numbers and values, this is something that we have to learn over time and has to be taught to us. So if we look at the picture on the left-hand side, it's pretty obvious that it's a male. He's looking at someone or something off camera. He's smiling, so he's happy, so he's joyful. So we can get a lot of information from that visual. But if you look at the equation on the right-hand side, 18 times 24, it takes us quite a long time to figure out what that equals. It doesn't come easily to us. It's not inherent to us. It's something that we have to learn and something that we have to put a lot of thought and effort into. So when it comes to values and rows and columns that most people are accustomed to, it is really hard to see any patterns or highlights. For example, if I asked you to count how many threes there are in this data set very quickly, it might be challenging for you to do it in like 1 or 2 seconds. Now if we add some sort of differentiator to these threes, we can count them much easier. This is the simplest form of adding visual elements to a data set to highlight specific aspects of that data set. So now if we look at all the threes, it's really easy to count there are 5 threes in this data set. So this is a visualization of the previous data set I just showed you. So it's pretty obvious that there's a pattern here. All of the values except for the number 1 are represented 5 times in the data set. You probably wouldn't have known that if we didn't visualize it as a bar chart. Surprisingly, it took a very long time for us to figure this out. In 1786, about 1,000 years after Al-Kindi began analyzing the letters used in the Quran, William Playfair finally realized that visualizing the data graphically is much more impactful than viewing the numbers. This line chart displays the import-export data from Denmark and Norway to England. By looking at the chart, you can see the crossover in the lines, and you can easily see when England started exporting more than it imported around 1755. He went on to not just invent the line chart, but the bar chart and the pie chart as well. Another great example of how powerful visualization can be is John Snow's cholera map. In the 1850s, cholera was believed to be an airborne illness. When there was an outbreak in London in 1854, Dr. Snow decided to collect all the data surrounding the outbreak and visualize it on the map. He noticed that the outbreak was centralized around a very specific area, and later, that the source of the outbreak was not airborne at all, but a contaminated water pump in the middle of the outbreak. So this was really the start of the study of public health and epidemiology. One interesting fact is that there was a little outlier around the pump. So here's the pump, and all these little tallies, these kind of look like bar charts, are the tallies of the total number of people that died from cholera. So this is the infected pump. And you can see that more people died around this pump than anywhere else. One outlier is that I believe over here, there was a brewery brewing beer. And the process of brewing beer required you to boil the water, which killed the bacteria that made everyone sick. So anyone that was drinking beer instead of water would have been fine. Now that we know how important it is to visualize our data, we have to understand the best way to visually interpret these values. It turns out that humans are very good at seeing the difference between lengths. We're not as great at seeing the difference between widths. And it's pretty much impossible to know accurately how long a line is compared to the perimeter of a circle. For thousands of years, we have been seeing patterns all around us in nature and in the skies. Specifically noticing constellations and star movement, helping us navigate the Earth and predict seasonal changes. So because of that obvious ability to see the patterns around us, that is also a good method to use when visualizing data. You can use enclosures to make clusters completely obvious. You can physically connect related objects with lines. You can use distance to imply clustering. And you can also use different shapes, sizes, and colors to represent related data points. Another issue that most of us have is seeing the difference between two sloping lines. On the left, we can see two lines, but it's pretty much impossible to accurately see how much of a difference in slope you have as they gradually curve up. It is much better to calculate the distance before and then plot that value as one line. So it's hard to see the distance between this point all the way up to this point. See if it's the exact same distance or not. So for this first one, it actually is the same. So there's no difference in these 2 points as you go up this curve. So it's really difficult for us to see the difference. So it's much better to plot it as one line, calculate it first, and then plot it as one line. Here is a very helpful spectrum that shows the most accurate visual comparisons, gradually going down to the least accurate. Again, we are really great at seeing the difference between different lengths of bars. So this area is probably the best area to use when it comes to visualizing certain data sets. And the majority of visualizations that you'll see are going to be like 90% bar charts. Slopes are kind of mid-range, so line charts and then pie charts, finding angles and comparing angles. Those are a little bit more challenging for us. Finding the difference between area is very hard to see. So the difference from this area circle to this area of the circle is very challenging. Color is also very challenging. Color intensity and a gradual tone from a lighter color to a darker color is a little bit easier. Volume, I would highly recommend staying away from working with 3D visualizations. It just really doesn't display the data in a very easy to understand way, and it's hard to see comparative differences between two three-dimensional objects. And then when it comes to color, color is very subjective. Everyone sees color and hue very differently. So that's usually the least accurate way to visualize a data set. You can use color as highlights, but as the main way to visualize the data, I would highly recommend avoiding that. So speaking of color, color can be very deceiving. Here it looks like the square in the center is swapping with the background color. But if you remove the background, you can easily see that they are actually the same color. Here's another example that some of you probably have seen that shows how everyone sees color and combinations of color very differently. So this is a dress that made its way around the internet a couple years ago, and people were arguing about whether it was a white and gold dress or a blue and black dress. So I'll let you decide what you believe it is, but that just is another point that color is very subjective. Everyone sees it differently, and it's very challenging to use as a main form of visualizing information. This looks like it's a progressive step from 1 to 5, but is actually doubling every single time. So whenever I talk about color, I always like to play this video from The Matrix. Hopefully I don't get sued for playing it in class.
The Matrix is a system, Neo. That system is our enemy. But when you're inside, you look around, what do you see? Businessmen, teachers, lawyers, carpenters, the very minds of the people we are trying to save. But until we do, these people are still a part of that system, and that makes them our enemy. You have to understand, most of these people are not ready to be unplugged. And many of them are so inert, so hopelessly dependent on the system, that they will fight to protect it. Were you listening to me, Neo? Or were you looking at the woman in the red dress? I was. Look again.
So color is being used really well in this scene when it comes to highlighting a specific aspect in the scene. So everyone was wearing gray or white or some monochromatic tone, except for the woman in red. So this just highlights one aspect in the scene and draws your attention to that specific aspect. When it comes to visualizing data, you can do the same thing. You can use color as a way of designing your visualization to draw attention to a specific aspect of that visualization. So color isn't great when it comes to representing the data, representing the numbers, but it can be used really well when it comes to highlighting or focusing on a specific aspect of your visualization. We also have to think about what colors mean in our culture. Each color can represent a very different mood or emotion. So black usually represents sophistication, gray is stability, purple is royalty, yellow is joyfulness, white is freshness, pink is romance, red is danger, blue is peace, and green is life. So when it comes to what you're visualizing, you have to think about the colors that you're using when it comes to what kind of mood or emotion you're trying to evoke from your audience. Here's a really great piece that's called Out of Sight, Out of Mind. And it's visualizing US drone strikes in Pakistan from 2004 to 2013. So this is an interactive visualization. So let's go to the website and check it out. So this is an interactive piece that starts with a bit of information about the topic, which you can click through. It has animation to it, interactivity, and it really uses color really well as well. So it starts showing all the attacks, all the US drone strikes in Pakistan slowly. It builds up. And then it gradually goes faster and faster and faster. So this piece is really powerful for many reasons. The topic is very powerful. The way it's put together and animated is very powerful and makes sense based off of the topic. It's very interactive. You can learn more about the people who died in these drone strikes. It also uses color really well to highlight certain types of people who died. So the bright red color shows the total number of children who were killed in these drone strikes. A darker red tone is the civilians. White are the high profile targets that they were looking to actually kill. And then this gray tone is all the other people that are either unidentified or can't determine if they were targets or not. It's really powerful how they're using the red to represent children, because that is the most innocent casualties of these strikes. So it makes sense to focus on that and bring that forward more than anything else. So you also have to take into account that not all cultures see color the same way. This is a beautiful visualization that shows 10 different cultures with 84 different moods and what colors are used to represent all those moods in those different cultures. If we take a closer look at death and love, we can see that there is a huge difference pretty much across the board. So it's important first to know your audience. So in Western cultures, death is represented by black and love is represented by red. Japanese, death is black, love is red. Hindu, death is white, love is green. Native American, death is black, love is yellow, etc., etc. So it is important to first know your audience before you start designing anything for them. So you don't want to use red to represent love if you're designing for a mostly Hindu audience. It is also important to understand how much detail to display in your visualizations. This is a great sell from Scott McCloud's Understanding of Comics. It is usually best to strip out the unnecessary detail, since the entire point of visualizing data is to make it easier to understand. You don't want to distract from the message. Although I do also believe that it is important for your visualization to be memorable as well as clear. So adding some design elements that support the overall theme is okay to include. So one really great example to look at when it comes to looking at detail is to look at the safety instructions for emergencies on aircrafts. So this one uses full color images and has way too much detail, in my opinion. It's really hard to see what you're supposed to be doing because the full color images really take away from a lot of the content of what they're trying to focus on. So whether it's buckling your seatbelt or preparing for an impact or where the exits are, it's really hard to see that information unless you really spend time and look closely at it. Here's another example that's a little bit better. It's using illustrations and less color to visualize all the safety and emergency aspects of the in-flight safety materials. So it's a little easier to see what you're supposed to do, how to buckle your seatbelt, what you're not supposed to do on a flight. But it's still, the woman's clothing is really bright and orange, and that is kind of distracting as well. So here's another one that uses illustration as well, but they're just line illustrations. There's no color when it comes to the people in the illustrations, and the more vibrant colors are being used for the flotation device and the oxygen mask that comes down from the ceiling. So that's what you focus on more than the environment or the people. Focus on the important aspect of the safety materials and the safety concerns for your flight. Another great example is if you live in New York City and ride the subway. The New York City subway map is very complicated and hard to navigate. So if you're a tourist and never been to the city before, looking at something like this is going to be intimidating and hard to figure out how to get from point A to point B. This is the old subway map from the 70s, designed by Massimo Vanelli. And although it's not geographically accurate per se, it's much easier to see what's going on and pull more insight from it. So the background is toned back. There's no green to represent parks. There's no blue to represent water. That's kind of arbitrary information. You don't really need that. More secondary or even tertiary information. So what you really want to focus on is the subway lines and the stops and the transfers and what trains go to what stations. The Massimo Vanelli map is much easier to navigate and see all of the more important information versus the current MTA subway map. So now there are many different ways to visualize data. Some might say there's an infinite number of ways to visualize any data set. A journalist for Visually decided to put together a pretty amazing story and study when it comes to looking at two quantities of values and seeing how many different ways they could visualize those two values. So this person ended up figuring out 45 different ways to visualize two values. So there's a line chart, there's icons, there's dot matrices, there's pies, there's areas, there's shapes, there's values, and many, many, many more. So this is just an example to show you that you can really get creative when it comes to coming up with concepts on how you should visualize any of your data sets. You don't have to go the traditional route of using line charts, pie charts, bar charts, etc. You can think outside the box a little bit, as long as it, I think, makes sense. That being said, there are certain chart types that work best with certain types of data. So bar charts are best when it comes to categorical data, so comparing apples to oranges to bananas. Line charts are great when it comes to looking at time-based data, so something that happened over a period of time from 1991 to 1994. Pie charts or donut charts should always be displaying parts of a whole that add up to 100%. Pie charts should never go above 100% or never go below 100%. They always have to add up to 100%. So here are some examples that use those types of visualizations. So these are from the Feltron reports created by Nicholas Felton. So here's a pie chart that's showing the different magazines that he read over the entire year. Here's some line charts that shows his activity, like where he went, or how many steps he took on a given day over a period of hours. Here is an area chart, which is very similar to a line chart, that shows what he's been reading over the last couple of years. Here's a dashboarding tool that was designed by Fathom Design for the Nike Fuel Band. So this is a area chart, which is, again, very similar to a line chart, that shows activity over the, I think, entire day. And it's overlaying multiple area charts on top of each other for different days. This is a donut chart that's showing your activity. This is a line chart that's showing your activity for the days of the week. And then another bar chart based off of your total number of workouts per week. So node-based visualizations are charts that take network data and find connections between all these different nodes. So looking at like your friend group, if your friend is John, then John is friends with like Sally and Sarah, and then Sarah is friends with Chris, et cetera, et cetera. Finding all those connections between different data points. Dot matrix is kind of like similar to a bar chart. It's using categorical data, so it's also comparative. So comparing apples, oranges, and bananas, and the total number of counts is represented by a dot. And then there's chloropleth maps. That's for geographical data. So that's changing the color of a state or a country depending on the value of the data for that particular country or state. So this is visualization by PopChart Labs, and it is a node-based visualization. So it's connecting point to point to point. So in this case, it's connecting the physical or metaphysical attributes of rap names. So it's breaking it down into like size and age and wealth. And then that's going from size to small to little, et cetera, and then finding all the names that are connected to those different nodes. Here's a visualization by Jer Thorpe that is looking at the connections between the New York Times stories for 2001. Again, this is a node-based visualization, so finding connections between the State Department and George W. Bush and the Taliban and the Senate and the FBI. Those are all connected to each other in the stories. Here is a chloropleth map. So this is changing the color of each state based off of whether they voted Republican or Democratic in the 2016 election. Here's another type of visualization that is geographic. So this is called a centroid map. So it's essentially drawing a bubble the size of the data point at a particular location. So this looks like it's drawing bubbles on top of counties. And again, it's 2016 presidential election data. So blue represents Democratic and red represents Republican. Here is another map that is showing geographic location by latitude and longitude points. So this is actually a personal trip that I went on with my father from San Diego all the way to Brooklyn. We did a little road trip, broke down a few times in like Utah area and Arizona area, but eventually made it back to Brooklyn. And this is the same thing. It's just visualizing it by connecting all those dots, connecting all those points. Here's another really great map visualization that is looking at weather data. This is by Hint FM. It's a design agency as well, and they do some really cool stuff. So this is an interactive piece, so let's check that out too. So this is a map that's visualizing weather data in real time. So it's taking data in real time and visualizing the wind patterns in the United States. So it looks like it's pretty windy around like the Denver area right now. But it's kind of cool. There's a gallery section too you can click on and look back. So if you were like in New York City in 2012, then you were around for Hurricane Sandy. So this is what Hurricane Sandy looked like in 2012. And then if you hover over it, you can see the wind speed and more information. You can click to zoom. So yeah, it's pretty impressive. So if you want to learn more about the best types of charts and graphs to use for your data, the DataViz catalog is a great website that breaks it all down for you. So if you go to the datavizcatalog.com, it kind of breaks everything down into different chart types. And then you could click on each one individually to learn more about that specific chart type and the data that is traditionally used with that visualization. There's also examples and also links to other tools that you could use to create those visualizations. So this is a pretty great platform to check out if you're new to this. There are a few other ones that are worth checking out, so make sure you go to the class website and click on the helpful tools section to see some of the other ones as well. Lastly, there are a number of bad habits that designers tend to make. This is one of them. So if you look at this, it kind of looks like just 4 bar charts, not a big deal. But if you look a little closer, you can see that 3 of them have a min and max that go from 0 to 100, and 1 has a min and max that goes from 0 to 50. So because this bar is right next to this bar chart, it gives the illusion that both of them go from 0 to 100. But in actuality, they don't. So this one looks like it's a value of 100 if you just look at this chart as well. So if you're just glancing at it quickly, then it looks like it's the same value when it's actually half that value. So for any visualization that you have multiple bar charts or multiple charts that are similar, you have to really stick to a consistent min and max value for that range. So the better way of visualizing this specific visualization is to change this from 0 to 50 to be 0 to 100 as well, to be consistent with the other 3. So another bad habit that I see a lot is playing around with and extending bars in a bar chart to be part of the design element. So when you expand like the bars down here, it visually looks like it's a lot larger value. So one example would be like using a bar chart and using it for like the extension of a American flag, and the bars on the flag represent that bar chart. That is skewing the data visually because it's extending the bars beyond where they should be going. So one thing that you could do is just like add a little gap in between or something like that, or think of another way to visualize your design. And again, when values of a pie chart don't add up to 100, that is a big no-no. So every pie chart should have values that add up to 100. So if it doesn't equal 100, if it's below 100 or above 100, then something is very wrong. So if you guys are interested in looking at other really bad visualizations, there's a great blog that was created by Drew Scow. It's called viz.wtf, and it's just a beautiful, terrible archive of some of the worst data visualizations you'll ever see. So if you want to know what not to do, go to this website and check out what he's posted to see what you are supposed to avoid. So the first tool that we're going to talk about using when it comes to data visualization and creating information graphics is Adobe Illustrator. Considering the majority of my students are design majors, this is a tool that you are probably already familiar with, but we're going to be specifically talking about using the charting tool in Adobe Illustrator. First, let's take a look at what not to do. I've seen a lot of designers bring in images of charts from Excel and trace them in Illustrator by hand. This is terrible for many reasons, but mainly you could be off when you trace the visualization, and thus the visualization will not interpret the data correctly. Another issue I see a lot is copying from another program like Excel into Illustrator. Although this is slightly better since all the sizes are correct, there tends to be a lot of glitches and you can't actually modify the visualization further with another data set. So today we are going to be playing around with Illustrator, using it the right way when it comes to designing charts and graphs in it. We will be using the graphing tool that is a standard tool in Illustrator, and many designers actually don't know it even exists. We can use this tool to accurately design most of the more common chart types, like bar charts, column graphs, stacked bars, stacked columns, lines, areas, scatter graphs, pie graphs, and the newest one is a radar graph. To input our data, we use the spreadsheet feature that is a part of the graphing tool. So you can either type directly into it, you can copy and paste from another spreadsheet, or you can upload a file as a TSV file, which stands for tab separated values, which is similar to a CSV, which stands for comma separated values. You can also have labels columns. It works fine if the data is a string of letters or words, but if it's a numerical value like a year, you have to put it in quotes. Otherwise, they'll think it's just another data column to be graphed. So here's an example of what you would get when you selected a bar chart and put in some values for years, for example. Now there's also a menu associated to this graphing tool, which gives you a lot of different options. So if you wanted to, you can view the menu from the menu bar at the top for object, and then go down to the graph option, and then that'll pop up type, data, design, column, and marker. You can also do a control click on any graph that already exists, and it'll pop this up, and it'll display the type, data, design, column, and marker. So let's go through each one of these individually so you know what they are and how to work with them. So the graphing type allows you to choose the type of visualization you're trying to visualize. So whether that's a column chart, stacked column, bar, stacked bar, line, area, scatter, pie, or radar. You can click on each one of these individually to switch the visualization type. You can change the value axis as well to be on the left side or right side. You can play around with different styles for like drop shadow, change the location of the legend, the first column in front, etc. You can also change for at least a column or bar chart, the column width and the cluster width. If you click on the graph options, you can change the value axis and the category axis. So the value axis allows you to change like the total number of ticks for that axis, whether they're short ticks or long ticks, or the entire width of the graph. You can also add prefix and suffix if you want to have like a percent sign or something. The category axis is the same thing. It just allows you to change the length of the tick marks, and then you can also change the division of those ticks. The next option is the data option, which is just your spreadsheet option. And this allows you to change the data in the spreadsheet. So you can type directly in this, you can copy and paste from one spreadsheet into this data table. You can also upload a file, a TSV file. When you click on that icon, you can transpose the data so it's transposed to a different view. And then you have to hit the checkbox to update the visualization when you change the data. The design option allows you to create designs for your bars, for instance. So if I wanted to make the bars, instead of just being rectangles, you can make them as arrows, or if you wanted to do something more graphic, you can do like pencils that you design, and then it'll extend the height of these arrows or pencils, whatever your graphic is, based off of the data. So how it works is you design a graphic, you select it, and then go to graph design option. You click on new design, and that's gonna pop up a new design in this menu area, and you can name it to whatever you want. I already renamed this to arrow, and then that can be used for any of your other bar charts or column charts to replace the bar or the column with the graphic that you created. So the column option basically allows you to apply your designs to those columns. So all of your designs that you created in the design area will be visible in the column option. And then you select that option, and then that'll replace the column or the bar in the graphic. You can also change the type of column it is. So if you want to do vertical scale, there's also uniformly scaled, repeating, and sliding. So vertical scale is just going to vertically scale the graphic, and it'll only change the height scale, not the width scale. So it's going to skew the scale a little bit. Uniform is going to scale uniformly, so it's going to change the width as well as the height. Repeating is going to just repeat that graphic every certain number of steps. So every 10 spaces, you'll have a little arrow that's stacked on top of each other. And then sliding is going to cut that graphic basically in half and then slide it up so it doesn't skew the graphic, it just extends it. So here is vertical scaled graphic. Here is uniformly scaled. Here is repeating. And here is sliding. So it's basically going to cut the graphic at the center point and then slide it up, so the graphic really doesn't get skewed. So marker is very similar to column, but it's basically used for, I think, line charts and scatter plots. So you could design a point, essentially, a graphic for a point, and then apply that graphic to the points on a line chart or the points on a scatter plot. So if you want to do any specific modifications, like changing the font, changing the font size, changing the thickness of the line, or changing the line to a dotted line, changing the color of one of these objects, the best thing to do is use the open arrow tool, and then you click on each one of these elements individually. The only issue with this is that if you update this visualization with new data, it's going to default back to the original default style. So the color is probably going to change, the type size and type font is going to change. So everything's going to be reverted back to the original stylistic elements. So that's one bad thing about using Adobe Illustrator. So I usually design a chart and make a copy of it, and then make my modifications to that copy. So I have the original. If I want to modify the original with new data, then I can. It's not going to affect my copy. And then if you wanted to make any sort of other modifications, once you have like the data is finalized and in there, then you can ungroup this element. And that is going to allow you to click on each one of these elements individually a lot easier. But if it's ungrouped, then you completely lose the ability to update this visualization with a new data set. Some of the other issues that pop up is that you can't automatically create a number for each column. So the value of that particular column or point, you have to manually put these numbers in there, which is kind of annoying. So Illustrator is a great tool, but there are definitely some negatives when it comes to using it for data visualization. So it's limited by the software's abilities. So again, this application was designed and built by programmers, so it has its limitations. It can't do everything. So you can't visualize complicated visualizations like maps or connected nodes or anything that's beyond the scope of what the charting tool allows. If you need to ungroup the visualization, ungroup the graph or chart, you can't modify it again with data. There's no automatic labels that get applied to your bars or to your points. And it's really not a great tool if you have to create tons and tons of visualizations based off of multiple data sets. It's not great for batch projects and multiple visualizations. So why don't we do a quick demo using the Adobe Illustrator graphing tool, and then we'll talk a little bit more about what you can do. Okay, so let's go ahead and open Adobe Illustrator and create a new project. I'm just going to create a letter project. All right, so we created a new project in Illustrator, and we want to play around with the graphing tool. So the graphing tool is going to probably look like this. It's a column icon. So if you click on that, that's selecting the graphing tool. To create a graph, then we click and drag. So this is going to create a graph based off of the size of where we're clicking and dragging. And then when we release, it's going to create in this case, a column chart. It's also going to automatically open up the data spreadsheet application. So here we can just type in values here. So let's create a column for fruit and say apples, bananas, and oranges. Then let's create a column for account. Let's say there's 20 apples, 35 bananas, and 40 oranges. So I type in here, I hit return, and it goes to the next cell. but as you can see, it's not updating the chart. So to update the chart, you have to click this apply button, and then it updates the chart based off of the data that you put into the spreadsheet. Cool. So let's close this. So now, let's say we wanted to play around with some different elements in the bar chart and the column chart. So if you do a control click, then it's going to open up this option window for type, data, design, then column and marker are grayed out. That's because we don't have a design in our design area yet. Well, you could also go to this, if you go to Object, Graph, and then it's the same menu. So let's go to Type, and let's change this to a bar chart instead. Hit OK, and then it flips it into a bar chart from a column chart. Let's go back to Type, and we can play around with the column width. So let's make it a little more narrow. Let's do 50%. And then it makes it a little bit skinnier. Let's go back to Type. Let's go to Value Axes, and you can override the ticks. It's going to automatically create a min and max value for you, but if you wanted to override that to be between like 0 and 50 instead, and ticks of, let's do 10. You can do that. So it's going to override that. Okay, if we wanted to go to the data again, if we wanted to add some new values to this, let's say we wanted to say, I don't know, grapes, and make that 36. And apply, then we could update that with a new data set. Okay, so another thing that we can play around with is design. So design allows us to create designs for these bars. So let's cancel this. The first thing we need to do is create a design. So I'm gonna design a arrow just by drawing a rectangle. And let's give this a color. Let's do blue. And no outline. And then I'm going to create a triangle. I like using the star tool to do this. So if you select the star tool, click, you can say, okay, I just want 3 sides, 3 points. Hit OK, and then it creates a triangle. And then you can rotate this and add it to your, let's make this a little smaller, add it to the bar, to the rectangle to make a arrow. So now I am going to also group these 2 objects so they are one. Okay, so we have our arrow, so let's move this to the side. I'm also going to rotate it. Apparently it has to be going straight up instead of left to right. Let's go to Object, Graph, Design, and we're going to create a new design. Let's rename it to Arrow. Hit OK. Hit OK again. And now we should be able to select our graph. We go to Graph, and then column and marker are now usable. So if we go to column, select arrow, then we can play around with these different options for the column type. Let's try vertically scaled first. Cool. So as you can see, it's kind of getting skewed because it's just vertically scaled, or in this case, horizontally scaled because it's a bar. So let's go back to column. Let's try uniformly scaled. So that's not skewing it, but it doesn't look very great because it's scaling the width and height. So let's go back to column and let's try repeating. This allows us to repeat this graphic every certain number of units. So let's say every 10 units we want to have a arrow. Cool. And then the last bit just gets squished, but you could also, if you go back, column, you could say chop design instead. That's just going to chop it at a certain point. And then the last option is going to be sliding, which I actually think is the best. So this kind of cuts the design in half and then slides it up. So nothing gets skewed. And the top of the visualization represents the full value for that data point. So now if you wanted to change anything beyond that, you would have to change it individually. So if we want to change like the font, we'd have to use the open arrow tool, select those individual elements, and change the font to whatever we want. Let's change the size, etc. And let's change the color of this one. Let's say we want to highlight the bananas. We can make them yellow or something like that. Cool. But now if I wanted to go back and change anything in the data, so let's say we want to go back in and say we got some more oranges. So we got 45 oranges. If we do that, hit apply, then at least the color reverts back to the original blue. But it looks like the type size stays the same. So the fonts stay the same, but any of the elements of the bar actually change back and revert back to the original color. So that's one thing you have to keep in mind. So there are issues when it comes to working with Illustrator and the graphing tool, but it's still a decent tool for creating visualizations that are data-driven. We're going to talk about some other tools as well, but this is, I think, a good starting point. So one other thing that you can actually play around with that breaks outside of the traditional use of Adobe Illustrator is you can write your own scripts for Adobe Illustrator. So you can write your own scripts to run through data sets and visualize something in different ways, for instance. With this, you could actually write scripts in JavaScript, which is a language that I'm very comfortable with. And here's an example of what you can create. So this is an Adobe script that is very simple. So what it does is that it goes through and creates a document. So it's creating a document. We're creating an RGB color. We're defining that color being red, green, and blue. We're creating a text value, adding some contents to that text, creating the type size, so the character attribute for that text, positioning it. So it's going to be from the top 400 pixels and from the left 200 pixels. And then we're also creating a rectangle that is going to be drawn at 200 by 400, and I believe is going to be 100 pixels by 500 pixels. And that rectangle is going to be the color red. So if you're interested in getting more into scripting with Adobe Illustrator, there's a scripting library that you can learn more about through the Adobe website, and this is the URL for that. I'll add that into the description below this video on YouTube, as well as on the class website. So if we just copy and paste this into a document and save it as a JavaScript file, then we can actually run this in Illustrator. So why don't we do that real quick, just so I could show you this actually running. So let's copy that. And I like to use Sublime Text Edit. And I'm going to paste this in here. And let's save this as test.js. And we can just save it to the desktop. Okay, so let's go back to Adobe Illustrator. And if we go to File, Scripts, and we can open other scripts. Go to the desktop, and then select that test.js file, open, and then it's going to open a new document for us, add some text there, and add this rectangle there. So it's going through all that code and creating this document for us. So you can imagine what we could do with this. We can run through data sets and visualize them in lots of different ways using Illustrator as a platform, but scripting and writing our own code to actually visualize it. So I actually do this for a lot of my own clients. I work with this organization called L2, where they work with a lot of data and they do a lot of reports. So I use the Adobe scripting tool to create scripts for them to pass through all of their data sets and visualize those data sets in Illustrator in a very specific way that is branded and has the right colors and right type size and fonts being used, and brings in the logos for these brands. using a data set that they provide to me just in Excel. So this automatically gets created when you run the script every single time, and because they have to do this, like, I believe weekly, it just makes it a lot easier for them to produce these rather than do them manually, one section by one section. So this is all the scripts that I've written for that particular project, and it loads in a CSV file, loops through all that data, and then visualizes it in a very specific way. So another platform you can take a look at is Processing. Processing is a programming framework, so it's kind of like writing scripts in Illustrator, but it's specifically designed for programming. And a lot of designers actually use this now for data visualizations, parsing through large amounts of data and applying those values to different visualizations or two different design elements. So here's just an example that's looping through a set of numbers and then visualizing it as a bar chart in this case, but it's also changing the color based off of the data. So the more yellow, the smaller the value is, and the more blue and red and violet, the larger the value is. So Nicholas Felton actually uses processing a lot in his annual reports to create some of the more complex visualizations. Jer Thorpe uses processing to create all of the visualizations that he's worked with in the past for the most part. So for example, the node-based visualizations of the New York Times data. Jer Thorpe also used processing to create a custom piece of software to help him decide where all of the names on the 9/11 memorial are going to be placed based off of their relationship to one another. So if they work together, they're going to be grouped together. If they were brother and sister, they're going to be grouped together. And he had all this data and used processing to create the software to help him determine what those groups should look like. And based off of that, the names were placed on the memorial. You can do some really interesting stuff with three-dimensional scans. So this is a visualization of a dancer. Again, using processing or a similar framework to take the data that they used to scan, that they used when they scanned this dancer, and visualize it using these particle systems that kind of look like sand or water falling off of their bodies. This is a piece by Kyle McDonald. It's called Face Substitution. And it's using code to basically do face detection and emotion detection and overlay someone else's face on top of his face. So you could do similar things in processing as well. And then my platform, Data Visual, first started as a processing project, specifically designed for my previous employer's project where they were working on lots of data visualizations for one of their clients doing these massive data books and websites. So I designed and built some custom software for them to use to automate that process of visualizing and creating those visualizations. So that basically saved them tons and tons of time and ultimately saved them lots of money too when it came to creating those visualizations for that particular project. So Data Visual started as a processing project for a specific job, for a specific client, and then turned into a more general purpose tool that is now web-based and JavaScript-based and can be used by anyone. So as a little in-class assignment, I want you to play around with some data sets that you have been looking at the last few weeks and use the Adobe Illustrator graphing tool to design a very simple chart. So make sure you use the right chart type for the data set you will be visualizing. So categorical data for bar charts and column charts. Chronological data should be used with line charts and area charts, and anything that's parts of a whole should be a pie chart. So check out the class website for any homework assignments we have for this week, And again, like always, feel free to email me with any questions or Slack me with any questions. I'm around. I'm here to help. And I look forward to those thoughts and questions and comments. That's all I have today. So thank you so much, guys, and I'll see you guys next week.